Hi everyone. Instead of making one really long video today, I thought I would make three shorter videos. This being the first one where I'm explaining different equations you can use for story problems for exponential functions. This is going to go over all of those equations we're going to be using, and then each of the videos afterwards are going to go through story problems from each of the different types of equations. So the first type of equation we have up here is for simple interest, just a little bit more what we've used to. I'm hoping that you've seen this a times b to the x before, and we will be using that a little bit, but mostly in this form where we have 1 plus or minus r to the x, where r is your rate of increasing or decreasing by a certain percentage. Just a reminder for percentages, if you have something like 3%. To write that as a decimal, you're going to take your decimal place and move it 2 spaces to the right and fill that in. So the decimal version is 0.03. You can also find that by dividing by 100. And there's actually kind of two hidden equations in here. I'm going to highlight that for us. So you see this plus or minus right here? The equation isn't going to have a plus minus. It's going to have a plus or a minus. You're going to be using a oops, that's still a highlighter. Wait 1 second. There we go. You're going to be using a plus sign when you see growth or increase. And you're going to be seeing, you're going to be using a negative sign when you see decay, decrease, or it depreciates. Depreciates? I think that's how you spell that. Not 100% positive. So that's when something is losing value. And we think about it like that because the 1 up here is, you can think of that like 100%. Oops. So if you have a growth of 3%, you're going to be adding 3%, and 103% as a decimal would be 1.03. So it would be like you're adding that 3% there. So again, you're adding when you see growth, increase, or appreciating. I should list that as well. And then you're going to be using the minus sign when there's decay, decrease, or depreciates. In this case, your a value here, this is your starting point, so whatever you have to begin with. X up here, so that's going to be your time, and then y over here is kind of the new amount that you get. And again, you can see that all right here. So that's kind of for simple interest. Moving down, we have compound interest problems, but there's a few different ways to do this. The last video that you're going to watch today is going to be about compounding continuously, but we'll get to that in a second. So the first formula is n times per year. So you can also use this equation when you're dealing with something annually or every single year. But if you have something that compounds quarterly, monthly, weekly, something like that, you're going to be using this equation. And it's a very similar equation, except now instead of plus your r, it's r over n, with n being your number of times per year. And then your exponent over here, instead of just being x, it's n times t. So your number of times per year times the amount of time. So we're using some new letters here. So A is your $n amount. P is your principal value or your starting amount. That 1 is still going to be here. And then this is always going to be a plus. We're going to use this whenever we are adding value to something. It's going to be r over n to the power of nt. So there is actually an example down here where our n is 4 times. So this is something that is happening quarterly or 4 times per year. So we're starting with $200. We have a rate of 6.2%, and they change that into a decimal. It's going to go up here. It's going to happen 4 times per year. So we have our 4 here and our 4 up here. And this is happening 5 times. So that's going to go right here, or over 5 years. And so they've kind of included all of that information there. So we'll go over more examples on, I believe, in your Friday's video. But I just want you to take a look at the number of times per year that they have over here for compounded. They have annually is 1, and again, you can just use this for that. Semi-annually is 2, quarterly is 4, monthly is 12. Again, weekly would be 52, daily would be 365, and we can kind of practice with different types of problems. So no matter how many times it's compounding per year, you're still going to use the same equation. Your n value might be different. But as those amounts get smaller, so weekly, daily, hourly, by the minute, by the seconds, it starts to compound continuously, and we start to get a more simple version of the problem. So this actually comes from this equation. So this e right here that you see, that e is not a variable. E in our case is a number, and you can see that right here. E is a constant it's about 2.71. If you take a look at your calculator, whether it's scientific graphing, what have you, if you type in E, if you type that button, it's going to appear with an automatic exponent because E has to have an exponent to it. So a lot of these same things still apply. We have A is our ending amount, P is our principal value, or what we start with. That'll be times E, so that's just, again, the number E, to the power of RT. So where R, again, is our rate, you have to change that percentage to a decimal. And T is time, usually in years, sometimes in months. We'll be talking about that in a bit. So these are going to be kind of our three equations. Other equations we're not going to be getting to this year. We've had to cut half-life problems as well as doubling problems. So if you have questions about any of this, let me know. Click on the next video to check out some story problems about compounding continuously.